So today we're going to be doing 8-5, which is called intercept form. So if you remember over the last couple days, we've been going over 8-3, which was standard. And so that's where you have ax squared plus bx plus c. In 8-4, we showed you vertex form, and that's the one that has the h and the k in it. So it looks like that. And so in today's lesson, they're going to show you intercept form. So again, these are just different ways somebody could throw a quadratic at you and ask you the same questions. So if you notice here, these are really the same questions, except for we have one new one and we don't have comparison. So very, very similar to what we've been doing. But just one little change. And so we'll talk about that as we get there. So let's write down what is intercept form. So intercept form, still have your A out front, which is your vertical stretch or shrink, but now they're going to throw some new letters at you. So they're going to go x minus p in parentheses, and then you're going to have x minus q in parentheses. And I apologize for, say, lowercase versus capital case. That doesn't really make a big difference here. I just don't like how my lowercase q's look, okay? But the lowercase to capital doesn't really matter. So this is still going to be our normal vertical stretch, shrink, reflection. That's your typical. But now we've got this p and q. These P and Q represent your intercepts. Actually, let me say your x-intercepts, okay? So what that actually looks like is where does it cross the graph? So let's say you had an example of x plus 1. Actually, let's do minus. It's easier to understand with a minus. Let's say you had x minus 1 and x minus 5. Because the subtraction sign is from the formula, this would cross at positive 1 and at positive 5. So these are called our intercepts. In order to find our axis of symmetry, we also have a little formula that we use, and it's p plus q divided by 2. So this right here, I know there's kind of stuff everywhere. This is really important in order to find your axis of symmetry, okay? So again, I think sometimes the best way to see this is just to give you an example and to kind of go through it. So if we take a look at number 1, notice we don't have a value out front here. So there's nothing out front, which is technically just a 1. So there's no vertical stretch or shrink, there's no reflection. So this would be our P and this would be our Q. Now, it's easiest almost to do your intercepts. So this is your intercept, but remember, we ignore that subtraction. So we have an intercept at 1, and then we got to be careful here. It's going to be x minus a negative 7. So our other intercept is at negative 7. Now, do you notice that I did not use a comma? You want to be very careful in this lesson about using a comma in different scenarios, because what you're trying to tell somebody is it crosses at 1 and it crosses at negative 7. So the parabola is crossing in those two places. If you were to list it like this, then someone might think that you go over 1 down negative 7. And so now they're like, is that the vertex or what is that? So you want to be really careful if you're talking about intercepts or if you're talking about the vertex. So we know that where this crosses. We know it crosses at 1 and we know it crosses at negative 7. Now notice I don't have graph paper here either, and that's okay. We can just do a rough sketch. We need to know where the vertex is. So we're going to use this axis of symmetry. Do you see how I'm doing these completely out of order? That's okay. We just go with what we have. So our formula is P plus Q. So we're going to add those together. So 1 plus negative 7 divided by 2. So that's going to be negative 6 divided by 2, which is negative 3. That is our axis of symmetry. So that means at -3, that's the halfway point of our graph, okay? We know that's our first part of our vertex. Now what we're gonna wanna do is take that number and plug it back into the original. So if we take the original, that's the original. Every time I see an x, I'm gonna put the -3. So I have -3, I have -3, and now I'm going to work this out. So this would be -4, this would be +4, and I multiply those together. And that's my second coordinate of my vertex. So man, this vertex is way down here, but that's okay. It doesn't really matter. We're just trying to graph it. We're just trying to give a rough sketch, okay? So we have our vertex, we have our axis of symmetry, we know where it crosses, we know that the domain is all real numbers, and now our range is y. Notice which way it opens. See how it's going up? It's going to be greater than or equal, and then we just need to know this number, which is our y coordinate. Now, they could ask us to do a comparison. If they did, which they're not going to in this one, but if they did, notice there's nothing out front, so we do not have a reflection, we do not have a vertical stretch or shrink. The only thing we would say is we would say that this moved horizontally left 3, and it went vertically down 16. That would be the only comparison. So if they ask us, just like they could ask us for max and min, look at your vertex. Do you see how it's the lowest? See how it's opening up? That must mean that this is a minimum. So there's lots of things they could ask us. Sometimes it just depends on what they choose. So just fill in the ones that they ask you for and don't worry about the other ones, okay? So number 2, notice here's our A. So this is our A, this is our P, and this is our Q. I'm going to go ahead and do my intercepts first. Just remember that this had to have been a subtraction. So in the original, this was x minus p. So this must be x minus a -2. So p must be a -2. So I'm going to say -2, and then I'm going to use an and symbol, not a comma, and then there's my q. Remember, the subtraction sign is from the formula. So q is just 4. So if I were to graph this, -2, 4, I know that's where it crosses. I also know it's negative, so I know it's going to be going down. It's just where is the vertex. So let's run our formula. -2 plus 4 divided by 2. I'm just using p plus q divided by 2. So that would be 2 divided by 2, which is 1. So my axis of symmetry is 1. I'm going to plug that in. And now I'm going to recalculate. So every time I see the x, I'm going to plug the 1 in. So I have negative, and I'm going to plug 1 in. I'm going to plug 1 in. And then I'm going to work this out. So I have -3 and then -3. So essentially -3 times -3 is 9. 3 times 3 would be 9. So this is 1 comma 9. So 1 and then 9, way up here. This is what my graph would look like. Remember, we're just trying to get a rough sketch. These do not have to be perfect. I don't have graph paper either. Just kind of get an idea of where these things fall. And then now we have our domain. And then look at our range. See how 9 is the highest? And it's going down. So this would be less than or equal to 9. Okay? So there's just 2 more examples on here. There is not a second page. So why don't you pause the video here and give it a try. Remember, all of these notes are uploaded online as well. So if you want to see a hard copy of them, you can. This is a 1/3, and then x plus 5, x plus 1. This is a -3, and then this is an x minus 2, and an x minus 3. This would be a subtraction. Remember, we don't have any divisions in this lesson. So go ahead and pause them here and give them a try. All right, hopefully you've tried them. On number 3, this is going to be your P and your Q. Just remember that you have to do the opposite. So it's going to cross at -5 and -1. So if we were to graph this, -1, those are our 2 crossing points. That's what the intercepts mean. It means where does it cross. The 1/3 just tells me it's a little bit wider, but I need to know the axis of symmetry. So I'm going to add them together, divide by 2. Remember, I'm just running our formula. So -6 divided by 2, that's my axis of symmetry. Now I'm going to go ahead and use my calculator for this one because fraction, I could do it by hand, but why not? Let's just plug it in. So I'm going to plug in the 1/3 into parentheses. And then whenever I see the x, I'm just going to replace it with my new value. And there's my y coordinate. Now, do you see how my y coordinate is a decimal? Who cares? We're not actually like really graphing this, super accurate. So we can just say -0.3 repeating. If you want to change it to -1 1/3, you can do that too. So at -3, it would be down pretty, it wouldn't be very far because, -1, -2, it wouldn't be very far down. And then that's what it would look like. So if you get a decimal, so be it. Just round it off. It's no big deal. All real numbers. Notice which way it's opening. So because it's opening up, we use the greater than, and then we just put down our y value. That's the nice thing about this lesson is that the decimals is really not that hard. It's not any harder to graph because these are just kind of rough sketches. All right, let's go over number 4 and then we'll be all done. So this is P and this is Q. So I pull these out as opposites. So it's +2 and +3. Whoa, that's going to be hard to graph because look how close together they're going to be. 1, 2, 3. Man, that's a pretty narrow graph there. That's okay. So it's crossing at 2 and it's crossing at 3. So I'm guessing my vertex is at 2.5. Okay, but let's go ahead and run our formula. We add them together, divide by 2. So that's 5 divided by 2, which is 2.5. So there's my axis of symmetry, which again, a decimal is a decimal. It's no big deal. Now we're going to type it in. So every time I see an x, I'm going to type in 2.5. And then I'm going to type in 2.5. Just typing it back into the original. And then I'll hit enter. Ooh, that's really small. So my vertex is 2.5, 0.75. I'm glad that we don't have to be real accurate because there's 1. So it's probably like right here. It's just kind of a really small, short graph, but that's all right. There we go. We've got our domain. Now look at our range. It's opening down. So this is the highest point, and then it's everything smaller. So we're going to say less than or equal to, and then we use that point up there. You really, really, really got to get these 3 accurate. If you don't get, the intercepts, then the axis of symmetry fails. And if you don't get the axis of symmetry, then the range is going to fail. So you really got to make sure of your first points and then kind of go from there. So now you have learned all 3 forms. We've gone through standard, we've gone through vertex, and now we've gone through intercept. So next week, we're going to actually take a day and we're going to shuffle these all together and we're going to have you try some kind of like a mixed practice. Because we know in a typical test or on an SAT, they're not going to give you all of the same type together. They're going to mix them around on you. So we want to give you an extra day to be able to do that. So hopefully that extra practice will help.